So in this part of the notes, we're going to look at even more definitions, kind of look at some reasoning behind what's going on, and then eventually, like I said in the last video, lead this up to what we call significance tests. So on here I just have this labeled as Chapter 14, Part 3b, because we are covering part of Chapter 14, but then Chapter 15 kind of involves a lot of these concepts as well, especially in terms of reasoning. So these two sections, in a sense, will be kind of tied together in this portion of the notes. Okay, so if you remember from the last video, I said that when we do significance tests, or really when we're doing a statistical experiment, we need to make two different hypotheses. Okay, we call them the null and alternative hypotheses. So first, our null hypothesis is really the statement about the population that we will be testing. So the null hypothesis is the statement about the population that we will be testing. Okay, so we are basically looking for evidence about this claim. So we are looking for evidence about this claim. Okay, so basically our null hypothesis, we're going to write or denote as H naught. This means null hypothesis. Okay, and for this we're always going to start out with equivalence. So our null hypothesis would be that whatever mean that we're looking at, or the population mean, is equal to our mean. So I'll of course show you examples of how this looks numerically, but for a null hypothesis we're basically going to start with equal to. Right, so for the alternative hypothesis, this is going to be a statement that a parameter is larger than or smaller than the value stated in the null hypothesis, or we could just say they're different from the value stated in the null hypothesis. Okay, so basically we're looking to find evidence for this statement about the population. Okay, so for the alternative, what we do is we start with equal to as our null hypothesis. For the alternative hypothesis, we could look at it's less than the null, we could look at it being greater than, or we could just simply say it's different than. So this will kind of take three different forms. They could take three different forms. I'll denote it HA for alternative hypothesis. Okay, and that's that the population mean will be less than the null mean. Okay, it could be greater than the null mean, or it could be just simply not equal to the null mean. So HA. Okay, so they'll kind of take this form when we go through that. All right, so first I'm just going to start with the basics, and that's figuring out how we can actually form our hypotheses based on the word. So I'm going to start with the basics, we'll look at how to form the hypotheses, then we'll look at the intuition behind the calculations we'll do for the significance test, and then we'll actually go through and do the significance test. But first we'll just start basic with our hypotheses. Okay, so example 1 says, the average hours of television watching in the US from a recent survey is 2.983 hours each day. Okay, so basically what this is saying is we see that we're looking at average hours just in the US, so that's what the population mean is. So what we're going to start with our null hypothesis is that the population mean is going to be equal to, so I'm just going to write M equal to 2.983. So we're just going to start there. Okay, now we have to read through the rest of this to figure out what our alternative would be. Okay, so I think that the average for BC students will be lower. Okay, so they're saying even though the population average is this, we think that at BC it's going to be different. So we think that if we look at a sample from BC, we would get a different value from that. Okay, we want to write the null hypothesis and the alternative hypothesis. So we wrote the null. To get the alternative, the key words we're looking for is in this. So lower, higher, different than, something of the sort. Since this says lower, our alternative hypothesis is that the average for BC, okay, is less than 2.983. And I can denote that as just mu less than 2.983. This looks kind of different because we're calling it mu still, but basically we'll eventually have more information and I think it will make more sense as to why we pick mu for that. Okay, I'm coming to the next part. It says the average hours of television watching in the US from a recent survey is 2.93 hours each day. Okay, so we still have that as being our null hypothesis. M mu equals 2.983. Okay, next part, I think that the average for BC will be higher. Okay, so if we're looking at that, if it's higher, we're looking at greater than. So I'm going to have mu greater than 2.983. Okay, keep going with this, just a couple more examples. Okay, the average hours of television watching in the US from recent survey is 2.993 hours each day. I don't know if the average for BC students will be higher or lower, but I don't think it will be the same as the national average. Write the null and alternative. Okay, so our null hypothesis is still going to be mu equals 2.983, but our alternative is just simply not equal to. We said that we don't know, so that means I don't really know if this is going to be greater than, I don't know if it's going to be less than, I just simply think it's going to be different. So with that, we would just say not equal to the 2.983. So last example, at least in this portion, says the average hours of television watching in the US from a recent survey is 2.93 hours each day. I think that the average for BC will be lower. Assume that the standard deviation for all BC students is 2.5 hours and that their hours of TV watching are normally distributed. Okay, so here we have the average still for the US. So that's still going to be mu equals 2.983. Okay, I think the average for BC students will be lower. Okay, we're still going to have mu less than 2.983, right? But here, notice they give us more information. So it says assume that the standard deviation for all BC students is 2.5. So what that means is O of X bar is going to be 2.5. Okay, and their hours of TV watching are normally distributed. All right, so this gave us more information, and eventually what we're going to do is take this information and use it for our calculations. But for now in this, we're just focusing on forming our null and alternative hypotheses.